In this video, we're going to create a database and some tables. Now, in your applications, you will simply issue these commands, these SQL commands, inside the application in code. It's a little easier to illustrate the concept using a database utility like the one I asked you to download in another video. So go ahead and open that if you haven't, or just follow along. And I'm going to first create a new database, and I'm going to call it Data Dragon, and the extension that I'm going to use is SQLite 3. This is by convention. This means it's a version 3, SQLite version 3 database. I'm not going to use the wizard to create any tables or execute any commands. Instead, I'm going to head over to this utilities execute SQL tab, which allows me to just type in raw SQL. At this point, we have an empty database called datadragon.sqlite 3 that has no tables in it. The first thing I want to introduce you to is the concept of database versioning. SQLite 3 has something called pragmas. Pragmas are little bits of metadata that it embeds in the database. One of those pieces of data is called the user version. So what I want to do is issue a command called pragma, which will retrieve this value. And I'm going to run this, and it returns me the value of 0. So we're going to use this piece of metadata to keep track of our database version. As we release new versions of applications, we may want to alter the structure of our database. We may want to add or remove tables. And we're going to use this user version to determine what the current version of the database is versus the version that we're expecting the database to be based upon our application. So I can set the version like this, and I'm going to execute this statement. And then if I turn around and interrogate it, it's now 1. Now that I've got the database version encoded in the metadata for my DataDragon SQLite database, I'm going to create some tables. So I'm going to use the SQL create table command, and it needs to know the name of the table. So I'm going to create a table called realm, followed by a list of columns, their types, and their constraints. So there are reasonable defaults for many of these, but I'm going to spell everything out that I want. So if you look quickly through here, I'm going to have a column called realm version. The data type for that column is text, and the constraint is that it's not null. Following on through, I have a CDN column, a champion version column, item version, etc. And I'm just going to go ahead and create this. So if I run this, and oops, I have to highlight the whole thing. If I run this command and then go look at my database structure, you can see that it created a table. So if I browse data, you can see here that it created a table with a realm version column, a CDN column, champion version, etc. So there's no rows in the table yet, but I do have a table. So let's head back and create some more tables. The next table that I want to create is my champion table. So this is just given it the command or the name champion. It has an ID, which is an integer. It's also the primary key. That means that I can identify individual rows uniquely in this table via this column. So this column must contain a unique value for each row. This is much like the other statement. I'm just going to run it, and we'll head over here to the browse data, and we'll see that I have a champion table with these columns. This happens to be the primary key, and again, there's no data in this table yet. I also want to introduce you to a new command. For the champion table, I want to query the data, and I want the data to be in alphabetical order by champion name. So in order to make that perform as quick as possible, I'm going to create an index on my table. On my champion table, I'm going to call the index champion index 01, and I'm going to have the index be built over the name column. This allows me to quickly sort or access rows by name. So I'll simply create that, and that created my index on my table. I have one more table to create, and I want to use this to show you an additional thing about defining primary key. So this just has a list of columns. You can look at that, but I'm using this primary key clause here because I have two columns that comprise the uniqueness for a row. The combination of the champion ID and skin number must be unique for each row. So this will contain a champion skin for each champion. So there may be more than one skin. That's why I need to use a compound key. So often it's helpful to use this primary key clause when you have a compound key. You can actually use it if you have a single key as well, but this is just an alternate syntax. So I'm going to go ahead and create that. And now I have my database defined. If we go look over here, I have three tables: the realm table, the champion skin table, and the champion table. And I created this index here on champion. The database automatically created an index for me for the champion skin because of my compound key. But you can see that the structure of my database has been created.